In this video, we are going to cover 6 of the chapter 7 exercises. Which of the following reactions proceeds with the highest regioselectivity? Here are 4 choices, 4 reactions, 2 chlorinations and 2 brominations, and each reaction could give possibly 2 regioisomers. Obviously, in each case, a mixture of 2 regioisomers will be obtained, and the question is, which reaction will give the highest ratio of the 2 regioisomers, that means highest regioselectivity? There are 2 ways to approach this problem. You can look either first chlorinations versus brominations, or, as I'm going to do, consider the starting alkanes. We have propane as starting alkane in examples A and B, or answers A and B, and tertiary butane in answers C and D. In propane, halogenation is that of primary versus secondary carbon atom. We know that secondary carbon atom is much more reactive towards free radical halogenation, and that means that secondary product 2-bromo or 2-chloropropane will be obtained predominantly. In cases C and D, tertiary butane, we have competition between halogenation of tertiary versus primary carbon atom. And there is much greater degree of difference in reactivities between tertiary and primary versus secondary and primary carbon atom. Order of reactivities is primary, the least reactive, then secondary, and tertiary, the most reactive. So in examples C and D, or answers C and D, we have the most reactive carbon atom, tertiary carbon atom, being halogenated versus the least reactive, primary. Obviously, those reactions are going to be more selective compared to reactions A and B, where a carbon atom of the intermediate reactivity, secondary carbon atom, reacts versus primary carbon atom, one of the least reactivity. That means correct answer is going to be either that of C or D. C is chlorination, B is bromination. Bromination is considerably more regioselective compared to chlorination. Chlorination actually exhibits relatively low regioselectivity, while bromination rather high. So for that reason, D is the correct answer. Next question, the following represents. And now we have one step in free radical bromination of cyclopentane. In this case, cyclopentyl radical reacts with bromine to give bromocyclopentane and bromine radical. So which step it is? And the choices are initiation, propagation, termination, or rate-determining step. Obviously, it is not an initiation step. In an initiation step, starting material is a stable molecule, and bond in that stable molecule is broken to give free radicals. That's why it's initiation step. It initiates free radical chain reaction, so free radicals are formed in that step. In this case, we have free radical as already on the left side as a reactant, and then free radical as the product. So it cannot be initiation step. It's actually a propagation step, B, because free radical is reactant on the left, cyclopentyl radical, and then on the right we have bromine atom or bromine radical as the product. And then that bromine atom will react in another step with cyclopentane to give cyclopentyl radical in second propagation step. So, or actually, if you draw the mechanism, that will be the first propagation step. This one represents second propagation step. Nonetheless, when you have free radical as reactant and then another free radical as a product, those are propagation steps of a free radical chain reaction. In the termination step, free radical reaction terminates. That means 2 free radicals will combine or would combine to form a stable molecule. And finally, rate-determining step obviously is not the correct answer. Chlorine reacts with methane by a free radical mechanism giving a variety of products. Formation of which of the following compounds points to a free radical mechanism rather than an ionic process? Characteristic of free radical mechanism is formation of dimers. So while compounds A, chloromethane, C, dichloromethane, and D, chloroform or trichloromethane, are all products of free radical halogenation, chlorination of methane. None of them point to a free radical mechanism. In fact, we could obtain them through other reactions. It's only product B, a dimer. Dimerization is characteristic of non-polar free radical reactions. That's product of a termination step where two methyl radicals combine or terminate, combine to form molecule of ethane. Only non-polar reactions undergo or result in formation of dimers. That's because free radicals which are not charged can combine, combining their free electrons to form a bond and form a dimer. If intermediate, carbon intermediate were charged, if it carried positive or negative charge, then two carbon atoms could not form bond with each other because two carbocations or two carbanions would repel each other and bond could not form. So for that reason, formation of dimers points to a free radical mechanism. Next question, what is the major product of the following reaction? We have reaction of ethylbenzene with N-bromosuccinimide in the presence of light. These reaction conditions result in formation of bromine radicals. Exposure of N-bromosuccinimide to light results in formation of bromine radicals. So this is free radical bromination of ethylbenzene. In compounds like ethylbenzene, so compounds with pi bonds, carbon atom next to a pi bond is particularly reactive. That's because free radical generated on that carbon is stabilized by the neighboring pi bond, and that radical is very stable, low in energy, so it's favored intermediate and will give the major product. That's why free radical reactions are particularly easy to accomplish in benzylic or allylic positions. This compound, having benzene ring, has benzylic position. Benzylic position is carbon attached to benzene ring, and that's where bromine substitution will occur, on carbon attached to benzene ring. That's carbon C. Name the major reaction product of the free radical reaction below. Obviously, we should first draw a formula of the product and then name that molecule. To do that, of course, we have to find out what is the product. Starting material is 2-methylpentane. 2-methylpentane has 3 primary carbons, 2 secondary carbons, and 1 tertiary carbon. In a free radical bromination, tertiary carbon is by far the most reactive. And that means that reaction will occur on tertiary carbon. So we should draw a product with carbon-bromine bond on tertiary carbon. And then name this compound, and that's 2-bromo-2-methylpentane. The intrinsic reactivity towards free radical chlorination of a tertiary carbon atom is 5 times higher compared to the intrinsic reactivity of a primary carbon atom. What is the expected ratio of the two monochlorination products? That obviously refers to the chemical equation shown here. So it's monochlorination of 1, 2, 3, 4, 5 pentamethyl cyclopentane, and there are two possible products, two possible monochlorination products. The first one is result of chlorination of tertiary carbon atom, and second one chlorination of primary carbon atom. So the intrinsic reactivity ratio is 5 to 1. That means that tertiary carbon atom is substituted 5 times faster compared to primary. Or each time one primary carbon, one hydrogen on a primary carbon is replaced by chlorine, 5 hydrogens attached to tertiary carbon atom are replaced by chlorine. So to do the calculation, we should start by counting the number of hydrogen atoms that are attached to tertiary and that are attached to primary carbon atoms. Shown here in red, there are 5 hydrogen atoms attached to tertiary carbon atoms, and each one has intrinsic reactivity of 5. it reacts at a relative rate of 5. And then, shown in blue, you can see that there are a total of 15 hydrogen atoms that are attached to primary carbon atom. And each one reacts at a relative rate of 1. So the overall ratio is going to be 5 for 5 hydrogen atoms attached to tertiary carbons. So 5 multiplied by 5 for the intrinsic reactivity ratio. That's 25. And for the primary hydrogen atoms, it's going to be 15, number of primary hydrogen atoms, multiplied by 1, intrinsic reactivity. So 15. So the ratio of the two products is going to be 25 to 15 or 5 to 3. This completes exercises that are related to Chapter 7.